left-sided heart?
No, this is right heart. Right side.
Yeah. Now, when you have right-sided heart failure, it's a little bit different. The right side receives blood from the inferior part of the body, including the liver, by the way. This is my rendition of a liver. Okay? The hepatic portal vein drains blood from the esophagus down to the anus. Everything that's metabolic waste, the liver usually cleanses it out, and then it sends everything that has CO2 to the inferior vena cava. Okay? It sends it to the right atrium. The superior part of the body that drains blood from the right and left upper extremities, from the jugular veins, from all the veins of the cephalic part of the body, the head, it all drains down into the superior vena cava. So again, inferior and superior vena cava are draining blood, consolidating it in the right side, and then hopefully it's going to send it to the lungs to get oxygen, right? But if you have right-sided heart failure, it's not pumping effectively. So it starts backing up. It backs down this way, and it backs up that way. This is where we get into the CVP that I talked about. You're going to have increased central venous pressure. Usually a pressure of 10 millimeters of mercury or more indicates right-sided heart failure. The reason why people have dependent edema is because the pressure gets so big in the vessels of the lower extremities that the blood starts spilling, primarily the plasma. It starts spilling outside of the vessels, and that's why you have dependent edema. Make sense? You'll have jugular vein distensions, which is what you picked on the exam question right there. The client's going to have hepatomegaly. Does that make sense? You guys good with that?
Mm-hmm.
That's heart failure in a nutshell. What medication do you give? You can give beta blockers, you can do that, but something more specific for heart failure. There's two types of medications that we're going to give.
It starts with S.
Okay, we can give diuretics.
Oh, just kidding.
That's the first line of defense. We usually give Lasix, right? We usually give Lasix because Lasix is a powerful diuretic, and so we give diuretics, in particular
Potassium sparing.
Lasix. Okay, we're not going to give potassium sparing just yet, unless somebody has an underlying pathological condition that causes them to have hypokalemia excessively. Then we give spironolactone, aldactone. Okay, what was that? Say that one more time.
Troponin.
The troponin. Well, troponin will be a cardiac enzyme that we read for diagnostic purposes. No, it's okay. Now, we give diuretics, and what else do we give?
You'll be okay, Joseph. You will live.
We give diuretics. What else do we give? So now we took care of the fluids, right? We can get rid of the excessive fluids. What else? Hydrazine is another, hydrazine is a powerful antihypertensive. We want to give diuretics, and remember, the heart is failing. So instead of its stroke, to be very efficient, it's kind of like this.
Or digoxin.
There you go. So now you give the two Ds, diuretics and digoxin. Digoxin increases the contractility of the heart muscle, the myocardium, right? It makes the stroke more efficient.
And afterwards,
Yeah, everything. Yeah, it increases afterload, decreases preload. It does what it's supposed to do, right? It makes the heart contract better. Here's my question to you guys. What is the implication, or what are the implications of giving Lasix and digoxin? What are the implications?
toxicity of digoxin.
Yeah, because this is how it works. Yeah. So let's pretend this is a heart cell, okay? This is a cell of the heart. Outside the cell you have potassium, and you just gave the client digoxin.